We're going to talk about DAC, and specifically in the context of augmenting human capabilities through robotics, brain-computer interfaces, and extended reality. So, I mean, how did we get here? So we started working with robots and brain-computer interfaces through trying to make intuitive, imagination-controlled quadrupeds. So imagination is the way that you actually could use a BCI. You just imagine something and then something else happens. And now we are looking into using different modalities to control a robot. So not just quadrupeds, but robots of here's a few clips of the things that we've done with this is the project using a BCI to control this dog to come towards and away from you. And these are for assistive purposes. So if you're unable to walk or communicate or anything that you'd need assistance with, we're developing ways of controlling robotic systems to be able to do that. Is of the dog identifying the person and then record, like going towards them and away, while also recording brain signals. So we've built a few prototype control methodologies. The first being EEG control. So if you were in Georgia, you would have seen this. Also here we've shown you guys some finger tap control, being able to control this thing just by tapping your fingers. We've also developed like hand gesture control. So just by making different movements with your hand, you can now control this robot dog. And then also through natural speech and talking to it. And also it is able to detect humans and then follow them. It can detect an individual human and follow just you if you want it to. And in terms of these demos, we actually are able to show you one of these live. Just give me one moment, because Ronald is setting up the BCI control. Okay, yeah. So he's calibrating the BCI control, so you'll be able to actually see what we've listed here, code modulated VEPs, and this is like a really robust form of BCI for those that don't know much about BCI. The way that this functions is you have a kind of button that flashes, and all you've got to do is look at it, and then that signal or that button causes a particular signal in your brain which can be picked up and then used to control the robot. So it looks like we have liftoff. So this movement is being controlled by Ronald's brain. Isn't it great? Move forward. Yeah, so systems like this could extend past quadrupeds. Could extend past quadrupeds to like assistive robotic arms. Maybe you have an arm attached to that you then can use to control other things. I'll show you another one on the demos.
Yeah. So this is one of the demos we have. Apart from BCI controls, we also thought of a few other intuitive ways to control, which is one of them is a wearable keyboard. And we control it by tapping the fingers, and different combinations makes it move in different ways. Sorry? And after this, we'll be also having a demo of a gesture-based control, and it's using a different type of network, which is called an echo state network, which Robert is working on. Now we're just setting that up, so is it connected? He'll try moving it backwards, but it might go forward, so it will be a good idea to. Yeah, so will you be able to show it? Will you be able to show it?
Yeah, so I'm using this wearable keyboard to be able to make this thing move. So just tap to the left, tap to the right. And you can control the movement of this dog quite intuitively. You know, you just walk with your fingers, and you can control this dog. So, yeah, if you only had control of your fingers, then this could be a way to control an assistive robot for something, whether it be a robot arm or a mobile robot like this.
Okay, so that was the first one, and now we'll look at the gesture-based control. And after we're done, if anyone is interested, you can come and try it out. So the gesture-based control, we do a bit of training, and the good thing about it is you just need to train it 3 times. I think that's what the results are. So we get good classification even with 3 trials and over 5 classes. Is that fine? Over 5 classes.
Yeah. So for the machine learning nerds, that's pretty good, because if you can train a whole neural network with 3 trials across 5 classes and it works, then you have a pretty good neural network in terms of training, at least.
Is it working? Do you want to show?
So there's a little bit of a lag between movement and it going, but it is doing the right thing. Sorry for those that can't see, I'm doing different hand movements, and I probably shouldn't show you, but this makes it stop. And then this makes it turn. So it's turning. I make it go forward.
Do you want to show that? I think it's not visible. Careful, careful, careful.
That one works.
Can
Other than this one,
okay, so let's move on from the demos. So why DIAC?
yeah, why are we thinking about DIAC in this field, like BCIs and robotics? And mainly it's because of some big advancements that have happened in big tech recently. So Snap has acquired a BCI company. And this was 3 years ago, actually. So they are working on acquiring their user base's brain signals to be able to use them for whatever means they wish. And it's not necessarily that they're using this for negative means, but there is definitely the potential for misuse. And the same is with Apple. So just a few days ago, they announced that they are now considering neural signals a native input, just as keyboard and mouse. So this means that in the very near future, we have big tech moving into brain-computer interfaces and neural data acquisition alongside all of the other data that they hold about us.
Yeah, so over the past few days, we have learned a lot about the things we're not aware about, like the privacy issues, and also how the sensor values can be manipulated. I think we are not really aware of that, but coming here and I think talking to the people around has given us more insight in this. So one of the biggest issues is, like Robert said, social media companies, like they have a large user base, and they are getting into BCIs and AI, and I think there's a risk over there because their systems are closed, and we need to start making open source systems which are quite attractive, because I think the social medias have good use cases, and with a closed system, they can flip the switch anytime. So I think we need to come up with good use cases which are open source as well. So in robotics, the various things we need to think about is, one is we are creating robots in the form of humans, and it's almost like creating an entity which is stronger than us. I think we should also look into enhancing the human body itself with technology before we head into developing robots in their own form. And the other thing is having modular hardware so that the user can modify their hardware based on their needs. And also, after that, we need to make sure we are empowering people rather than taking their jobs away. I think people can slowly transition into this new world if they are allowed to train the robots.
In terms of DAC for brain-computer interfaces, though, people have already started to think about this in the neuroethics field. So neurorights have come about, which are a set of ideas right now. Nothing has been put into actual legislation about how neurotechnology should be developed and deployed. But we really think that this isn't enough. We should actually build this into the technology, and having people have ownership of their neural data locally is probably one of the best ways to kind of have self-sovereignty of your neural data. But then also on the neurotech device itself, we need to have pipelines that are FOSS, so free open source, and have open standards around how we actually develop BCIs and have standard formats. There are a few, but nothing has been really pushed forward more than the other. And all of these systems should be credibly neutral. And in terms of DX for XR, we see that there are a lot of people developing different types of shared spaces in the extended reality world, but these aren't necessarily governed by the community that use them. We see that this could be a very good way of putting DAC in the XR field, and then also making these XR experiences public infrastructure. So it really doesn't matter what type of device. I mean, yes, there will be some restrictions, but it doesn't matter what type of device or how much money you have or anything like this. You are still able to access these extended reality, this XR infrastructure, because at the end of the day, it will enhance human capabilities. And then in the same way, we should also have open standards.
So over the past few days, we have met multiple people and found interesting projects we can work on, such as verified actions from the robots, and also using cryptography on the BCI signals, because I think it's not thought about much by the companies that's pushing out these different modalities of control using BCIs. And in this space, we have people who are actually thinking about it. So we are looking to partner with other people, create projects, because I think this is a use case people actually see when we talk about cryptography. The people in the public are not actually thinking about how secure their network is, but when you have use cases that are attractive, they are more keen to using those things. And when we have such measures put into devices like this, we can make sure that the user is always safe and they also have full control over their data.
So in terms of things that we've started to build, one project that we're calling Reach uses AR or XR and a BCI to be able to connect to robots or just computers in general. This is a schematic of how it would work. It's quite intuitive because what would happen is in AR you would see the object, it would have a marker which you simply look at, and then you can then guide a robot towards it or just select it in some way. This is something that we've started to build. We still need bits of equipment, like reducing from a VR headset to AR glasses would be perfect, but yeah, this is just one thing that we're working on.
And the other project that we're working on is called the state of mind. So apart from controlling an external body, we also need to learn how to control our own minds. It's not only for people who have mental health issues, but I think everybody needs to gain a bit more control over their minds. I mean, it helps us navigate life better. So this project helps us visualize our minds using different colors and shapes, and also audio cues that come out based on the brain signals. Yeah, that's it. And thank you, and join us in shaping human acceleration. Thank you. If you have any projects and think of working with us, this is the QR code, and I think we've already spoken with many people around here, found interesting projects, seeing how we can make a good project out of it and also include different domains rather than just few of them, because I think we are supposed to collaborate somehow and find a good use case with all of them. That's when the people outside this bubble are aware of what they need to look into. Thank you.
So when you say mind control in this last one, that I imagine it's like training your own brain, like you train muscle to have muscle memory at some level. What does that look like? Is that like a BCI sensors that I'm wearing and getting like feedback? How do you envision that interaction happening?
It would be a visual feedback. Yeah, it would be a visual feedback from the brain, and also audio feedback from the brain. And how it works, I'd give Robert to explain that.
Yeah, so let's just take a wave that you might have heard of, like alpha waves. So these are very dominant in the brain when you are relaxed. So let's say that you wanted to make sure you get into a more relaxing state. You'll be instructed to relax, and then you can kind of choose how you want to perceive your change in mental state. So this could be audio, so you could have like shapes appear, or sorry, not shape, or you could hear something and that would change the tone, or you can have it visually where shapes would appear, or what we have right now is a particle system that kind of moves around and you can make it pulse. So in terms of this, it's just any way of then visualizing something that we know is related to a particular mental state, and then learning how you yourself can change what you're doing in your mind to cause this by getting that feedback. Yeah.
Any other questions? Well, no. All right, thank you. Oh, no. Thank you both so much, and that's it for the DIAC afternoon. We will have a short transition now for 15 minutes into the cypherpunk evening sessions. Thank you again.
Okay.